Our universe is a vast and mysterious place. We've peered deep into the cosmos, uncovering wonders beyond imagination. Yet a profound mystery lingers, a cosmic puzzle that has baffled scientists for decades. It's the enigma of dark matter, an invisible substance that dominates our universe. Imagine a dance, a celestial ballet of stars swirling within a galaxy. But here's the catch. The stars move faster than they should. It's as if some unseen force is tugging at them, accelerating their cosmic waltz. That force, my friends, is the gravitational pull of dark matter. Dark matter is a cosmic phantom, unseen and elusive. It doesn't emit, absorb, or reflect light, making it invisible to our telescopes. Yet its gravitational influence reigns supreme, shaping the destinies of galaxies and the very fabric of our universe. The existence of dark matter challenges our understanding of the universe. It suggests that what we see, stars, planets, galaxies, is just a tiny fraction of what's really out there. A cosmic ocean of dark matter surrounds us, holding the universe together in its invisible embrace. How do we know dark matter exists if we can't see it? It's like detecting the wind, not by seeing it, but by observing its effects. We can't touch dark matter, but we can see its fingerprints on the cosmos. One compelling piece of evidence comes from the rotation of galaxies. Stars and galaxies orbit the galactic center, much like planets orbit a star. However, when astronomers measured the speeds of stars in spiral galaxies, they stumbled upon a baffling discrepancy. The stars were moving too fast. The visible matter in a galaxy couldn't produce enough gravity to keep these speedy stars from escaping into the vastness of space. It was like watching a merry-go-round spinning so fast that the horses should fly off, yet they remained in their circular dance. This unexpected observation led scientists to a profound realization. There must be some invisible matter, a hidden gravitational glue, holding these galaxies together. And so the concept of dark matter was born. The evidence for dark matter extends far beyond the curious case of spinning galaxies. Like detectives piecing together clues, astronomers have uncovered multiple lines of evidence pointing towards the existence of this elusive substance. Gravitational lensing provides another compelling clue. Imagine light from a distant galaxy traveling towards Earth. If a massive object, like a cluster of galaxies laden with dark matter, lies along the path of this light, the object's gravity can bend the light's trajectory, acting like a cosmic magnifying glass. This bending of light, known as gravitational lensing, distorts the images of distant galaxies, creating arcs, rings, or multiple images of the same object. By studying these distorted images, astronomers can infer the presence and distribution of the invisible mass responsible for the lensing effect, dark matter. Further evidence comes from the cosmic microwave background, the faint afterglow of the Big Bang. This ancient radiation carries with it an imprint of the early universe, like a cosmic fingerprint revealing its composition and structure. Section 4. The Hunt for the Invisible. Dark matter's exact nature remains one of the biggest unsolved mysteries in modern astrophysics. What is this invisible substance made of? Scientists have proposed a plethora of candidates. One leading contender is weakly interacting massive particles, or WIMPs. These particles interact very weakly with ordinary matter. If WIMPs exist, they should occasionally collide with atoms, leaving a faint signal. Another possibility is axions, ultralight particles. Axions could be produced in star cores and detected through electromagnetic fields. The search for dark matter is a global endeavor, with experiments deep underground and in giant accelerators. Section 5. The universe's missing pieces. So, why is dark matter such a big deal? Why are astronomers and physicists so obsessed with uncovering its secrets? The answer lies in the profound impact dark matter has on our understanding of the universe. You see, dark matter isn't just some cosmic curiosity. It's the invisible scaffolding upon which the universe is built. Its gravitational influence shaped the early universe, seeding the formation of galaxies and galaxy clusters. Without dark matter, our universe would look vastly different, perhaps devoid of the structures we observe today. Moreover, understanding dark matter could revolutionize our understanding of fundamental physics. The standard model of particle physics, our best current description of the subatomic world, fails to accommodate dark matter. Discovering its true nature could lead to new physics beyond the standard model, unlocking a deeper understanding of the universe's fundamental building blocks. Section 6. Unlocking the cosmos's secrets. The mystery of dark matter is a tantalizing reminder of how much we still don't know about the universe. It's a cosmic puzzle that has captivated scientists for decades, and its solution promises to revolutionize our understanding of the cosmos and our place within it. As we delve deeper into the invisible universe, we embark on a journey of cosmic discovery. With each new experiment, each new observation, we move closer to unveiling the secrets of dark matter. And in doing so, we unravel the story of our universe, a story written in the language of gravity, light, and the enigmatic dance of the unseen.